Hello everyone. I'm Nisar Sheikh. So welcome you all on this lecture of engineering graphics and CAD, where we are going to see the MCQ on the first chapter, that is the projection of line. Okay, so we'll start it. Okay, so we'll see first MCQ. So I'll read the question. A line AB of the length 100 mm is parallel to horizontal plane and inclined to the vertical plane at 30 degree. What is its length in the top view? Okay, so this is the question. So we can read that sentence once again. So if you see, so what is given here? So here the line AB is given, whose length is the 100 mm, and which is parallel to the horizontal plane and inclined to the vertical plane at the 30 degree. Okay, means if you see, so whatever this condition is there of the line, so it is of the horizontal line. Okay, means the line which is inclined to vertical plane and parallel to the horizontal plane. Okay, so we have seen what is meant by the horizontal line. So we are knowing that. So in case of the horizontal line, okay, so whatever the true length is there, so we are getting in the top view itself. Okay, yes. Now what is asked here? So what is its length in the top view? Okay, and as per the definition of our horizontal line, so whatever the true length is there, so we are getting in the top view, and already here you will see, so true length of line is the 100 mm. Okay, means so what are the answers we will get? So definitely it will be the 100. Okay, 100 mm. Because so whatever our top view is there, so it's showing the true length. Okay, so here option A will be the correct. Okay, now we'll see second. A line PQ of length 80 mm is parallel to vertical plane and perpendicular to the horizontal plane. What is its length in the front view? Okay, so you'll understand the first of all what is the question. You can see here, so the line PQ is given of the uh, length 80 mm, and so it is parallel to the vertical plane. Okay, means whatever this line is there, so it is a parallel to vertical plane and perpendicular to the horizontal plane. Means in the uh, top view, so we'll get an point view. Okay, and in the front view, so we'll get an line, so that will give the true length. So whatever the front views we are getting, so that will be the perpendicular to xy, and whatever that front view is there, so it is going to give the true length. Yes, what is the question here then? What is its length in the front view? Okay, and as I have told that, so whatever is the front view is there, so it's showing the true length. Okay, so now you will see here, so whatever the true length is there, so in case of this the 80 mm. Okay, and whatever our front view is there, so it is also giving showing the true length. This how whatever our answer is there, so C will be corrected. Okay, so we'll see next one. Third one, a line RS of the length 80 mm is parallel to vertical plane and perpendicular to horizontal plane. Then what is its length in the top view? Okay. Now if we'll check out, so here, so whatever this line is there, so same condition is there, so that we have seen in the second question. Okay. So what just changed here? So in that previous one, so what they have asked, so length of that line in the front view, and here, so what they have asked here, so what will the length in the top view? So as I told in the second question, so whatever it's a top view is there, so we are getting a point view. Okay, that means whatever the length is there, okay, uh, whatever we are getting in the top view, so definitely it will be 0 as we are getting the top view. So that's why the answer B will be here correct. Now next, fourth one, apparent length of line is always dash dash its true length. Okay, so as we are know that, so we have solved the number of problems on this. So what is the apparent length? Okay, so whatever these apparent lengths are there, so we are showing it by the uh, so in case of the problem, so definitely, so that will be less than its true length. Okay, so that's why here answer B will be the correct. Now next, fifth one, apparent inclination of the line is always dash dash its true inclination. Okay. Now, as again, so we have seen, so whatever apparent inclinations are there, so we are showing it by the notations like alpha, beta. Okay, and what are the true inclinations are there? So in the problem, so we are using the notation for that as the theta, phi, etc. So in that we have seen that. So what are the alpha and what are the beta we are getting? So it's always greater than the theta and the phi. Okay, so that's why here answer A will be correct. This apparent inclination of the line is always greater than its true inclination. Okay. Then next one, six, front view of the line MN uh, appears as a point. Okay. The line should be perpendicular to which plane? So that is asked there. So options are here: horizontal plane, vertical plane, profile plane, and the along XY line. Okay. And now, so you will see the condition is front view of the line um, and MN appears as a point. Okay, this when, so front view will get as a point when that line so will be perpendicular to the VP only. Okay, then and then we can get the front view as a point view. So here answer will be the B. So vertical plane is the line should be perpendicular to the vertical plane. The next, when a line parallel to XY line, so which of its views will show its true length? Okay. We suppose here, so whatever line is there, so that we are getting parallel to XY in the both views. Then, so which views will show its true length? So in this case, so C, so option, so it will be correct because what are the front view and the top view, so both will give the true length. Is when that line so will be parallel to the XY line. Then next one, both front view and the top view of the line CD are perpendicular to XY. The line in this case is called as. So here are the option: first horizontal line, B frontal line, C profile line, and none of these. You will see here. So when the both front view and the top view of the line are perpendicular to XY. Okay. So whatever this case is there, so it is possible when, so whatever line is there, so is perpendicular. Means what you can say? Means whatever this line is there, so it is inclined to HP and VP and parallel to the PP. At that time, so whatever the your front view and the top view is there, so you will get perpendicular to X1. Okay, that means, so whatever this line is there, so we are calling it as a profile line. So we are knowing the condition or the definition of the profile line is when the line is making an angle with respect to HP and VP, or what you can say when the line is inclined to HP and VP and parallel to the PP. At that time, so what is the line we are getting, so that we are calling it as a profile line. So here option C will be correct, that is the profile line. The next one, ninth, for a profile line, the sum of its true inclinations with HP and VP is 90 degree. Okay, is it as I have mentioned in the previous one. So in case of the profile line, so whatever the profile line is there, so it is inclined to HP and VP. Okay, and parallel to the profile plane, that is the PP. Okay, means whatever that line is there, so it is making angle with respect to the uh, HP and the VP. Okay, then at that time, so whatever its sum is there, okay, of that theta and phi. Means suppose theta is the angle made by that line, profile line with the HP. So that is the theta, and when it's making angle with respect to HP is the that phi. Okay, so this addition so must be an 90 degree. So then we are getting it, getting that line as a profile line. So that's why here angle should be 90 degrees. So these things we must remember here. Okay, means theta plus phi is equal to 90 degree in profile line. This profile line is there, then theta plus 90, theta plus phi, that must be the 90 degree. Next, the grade of line represent its dash dash inclination of the line with the HP. So already we are knowing that. So grade, okay. So from the grade, so we are getting the true inclination of the line with the HP. So that's why here answer. So A will be correct. This grade of the line. So represent its true inclination of the line with the HP. So option A will be correct. Then next, the bearing of the line represent its dash dash inclination of the line with VP. So is in the last problem. So as we have seen that is whatever the grade is there. So if grade is there, then it's showing the true inclination of the line in the front view. In the same way, so if bearing is there, then bearing of the line so represent its apparent inclination of the line, okay, in the top view or with the VP. So here the answer will be the B. This bearing of line represent its apparent inclination of the line with VP. Okay. So whatever these MCQs are there, number 10 and 11. Okay. So these are the just definitions of the gradient of bearing. Okay. If bearing is then, so it must indicate the apparent inclination of the line with VP. And if grade is there, then it must indicate the true inclination of the line with the HP or in the front. Then next one, that is the 12th one. In the projections of frontal line, bearing can be described as, so there are the options are there: due east or the due west, then B due north or the due south, C both of these, and D is the none of these. So let's see. So first of all, so we must know, so what is the definition of the frontal line? Okay, this frontal line, okay, this whatever this frontal line is there, the line which is parallel to the VP and inclined to the HP. So that line we are calling it as a frontal line. Okay, and if you see, so whatever the front view we are getting in case of the frontal line, so which is inclined, and that giving the true length of that frontal line. Means in shortly, what we can say that, so whatever the front view is there of the frontal line, so it gives the true length, and whatever the top view is there. Okay, so top view so will be in a line, so that will be uh, parallel to the x1. Okay, means whatever front view is there, so we are getting, so that will be the inclined line. Okay, so that will give the true length, and whatever the top view is there, so you will get an, in the top view, so you will get an apparent length, okay, of this of frontal line. Okay, and definitely that will be the parallel to x1. Okay, and as we know that, so what is the bearing of the inner line, so we're getting in the top view itself. Okay, and so as I have mentioned, so as I have told that, so whatever the top view of the frontal line, so we're getting as an a line which is parallel to x1. Okay, so that's why, so whatever its bearing is there, so either so it will be due east or due west. Okay, so that's why here option A will be correct, due east or the due west. The next, when two lines are parallel to uh, each other, okay, then they will see the options. So they appear parallel in front view and top view. When one line shows the true length, then other line also shows its true length. Then see distance between the parallel lines is seen in the view where both lines show their point views. Okay, simple C. So whatever this A, B, C, so this all these options are correct. So that's why. So here option D will be correct. So all of this. So one thing, so we have to remember in case of the parallel lines. Okay, that if the lines are the parallel, okay, to each other in one view, then they must remain parallel to each other and each other in the each and every view. Okay. So next we'll see angle of 90 degree between the perpendicular lines is seen in the view where. Okay, this where this what is the question that so when will you get the 90-degree angle between that perpendicular lines? Okay, so first option, at least one line shows its point view. Then second, at least one line shows its true length. Both line show their point view. None of this. Okay. Actually, in case of the concept of the perpendicular lines, so there are the two possibilities are there where we can get the angle of the 90-degree between that two lines. One is that is whatever that two lines are there. So both the lines, if they are showing the true length, okay, at that time we will get the 90-degree angle. Or so out of that two lines, at least one line so must show its true length. Okay, then we can able to see the 90-degree angle between that two lines. Okay, is so that's why here option so B will be correct. Is that at least one line show its true length. Okay. Let's see next one. In case of the uh, intersecting lines, we'll see option A. The point of intersection lies on the same projector in the front view and the top view. Okay, so this is the correct because in case of the intersecting lines concept, so as per its definition, so we are knowing that this point of intersection, so that we are getting in the front view, and the point of intersection of that two lines so that we are getting in the top view. So that must lies okay on the same project. Okay, so the front view and top view. At that time, we are calling it as that intersecting lines. Okay. So opposite to this, we are knowing that means when we are calling it as a skew lines. Means in case of the skew lines, so whatever this point of intersection is there, so it never lies on the same project. Okay. So that's why we must remember. So in case of intersecting lines, whatever the point of intersection is there, so it always come on the same project. Let's front and top. Next, uh, one base edge of tetrahedron and the opposite slant edge represent a pair of okay first parallel line, second perpendicular lines, third intersecting lines, and the fourth is the skew lines. Now so here so we need to understand, so first of all tetrahedron. Okay, because so suppose if we'll consider the tetrahedron. Okay, and so it is rested on its triangular face. Okay, so as per this question, so one base edge okay of tetrahedron and the opposite slant edge represent a pair of okay. Means it will so consider so whatever that's that two lines okay, so these two lines so it will be an skew lines okay, because when you observe from the front view so they looks like an as an intersecting okay, but they're not intersecting okay, so that's why so this will be the uh, skew lines, so option so it will be correct. Next one, the bearing of the line is given as a south 30-degree east. The apparent inclination of the line with VP is okay. Now, so it's very simple. So that we are knowing means whatever the bearing is there. So south 30-degree east. Okay. So whatever this 30-degree angle is there. So in case of this bearing, so it is with respect to the vertical direction. That means with respect to south direction. Okay. And whatever our beta is there. So that is with respect to the xy line. Okay, this 90 minus 30. So whatever that apparent inclination that is beta is there. So it must be the 60 degree. So option so A will be correct. Then next 18 bearing of line AB is south 40-degree east with respect to point A. Then its bearing with respect to B will be okay. So while solving the problem, so this type of the bearing so we have converted means here so whatever this bearing is there so it is given with respect to point A okay, so with respect to point A is south 40-degree east, that means definitely with respect to point B So it will be north 40 degree west. So that's why option B will be corrected. Then next 91. So grade of line PQ is 100%. Then what is the inclination of the line with HP? Okay. So here, if the grade of the line is 100%, then whatever is the that x distance and the y distance in case of the grade, so that will get the same. Okay, and if it is the same, then we can easily tell that, so whatever the angle, so for the inclination of the line with HP, so it will be the 45 degree. Okay, and the last one, the 21, locus lines drawn through the ends of an oblique line are. So here, so while solving the problem, so we have seen that, so whenever we are going to draw the locus line, okay, so whatever the locus lines are there, so that we're drawing, so parallel to the xy line. So here, that's why option A will be correct here. Okay, so these are the MCQs on the first chapter, that projection of line. So we have seen here. In the next lecture, so we'll see the MCQs on the or second chapter, that is the projection of the plane. Okay, so we'll stop here. So thank you.